Have you ever wondered why it is that when you put your thumb in front of your face like a foot away and then you close your eye one at a time, your thumb seems to move even though you know it's in the same spot? Well, welcome to Sketch Science, where today we're going over the idea of parallax. What does parallax mean? Well, you might ask yourself, why do I need to know this? How does this apply to anything around us? Well, when we talk about space and parallax, it actually means a lot. And it's actually why people, even with the geocentric, remember we talked about that before, how wrong it was? People use parallax as proof why it was right because of the tools they had. Well, parallax. Let's go over the word real quick. What do you notice about parallax? Maybe the beginning. What else is like that? Well, maybe parallel. Parallel lines. Well, think about it. When you're looking at something, you stick your thumb in front of your face, you close one eye at a time, it seems to move, right? Well, because your eyes are on different planes. They are parallel to each other. So when they have to move inwards, it's like a cone. It's the same idea with parallax. If you were to have a camera here and a camera here, and they're both facing the same direction outward, those are parallel lines. That's the direction the camera takes. This is how parallax works. If those are your 2 points of vision, if you have an object over here, well, this camera is going to move it over here. This camera is going to come over here. If you were to move it away this far, the lines are a lot shallower than they were before. That's the idea of parallax, is how steep these lines are going to be when you look at something from far or close from two different points of view. So if you were to have a spot here and a spot here, those are your two cameras. Those are your eyes, let's say. And you put an object right between them. This spot right here. Well, those lines are going to be pretty narrow, or pretty steep, I should say, depending on how you look at it. They're pretty flat. They're close together. It's going to come in. Up top, though, if you move it out, those lines are not nearly as much. They're steep if you're looking from the bottom, but they're flatter if you're looking from the side. Those lines are a lot closer together, way further out. They're not nearly as sharp to the point. The further out you get, the more steep it's going to be. There's going to be a lot less difference in how far you see things away. Now, if you take it this way, where you look at space, if I was to simulate space to this star out here, if I was to say this star out here and this star right here, how far are they apart from each other? Well, back in ancient times, take into account that this dot here and this dot here, that dot there is both of your eyes. If you were to draw two lines out from those points, here's line 1, here's line 2. There's really no difference. They overlap with each other. So you're not going to really be able to tell that those stars are so far apart because you're so far away from them that your parallel lines mean nothing to those stars. So when they were looking out from Earth back in ancient times, you have these astronomers, these Greek guys. They're standing up on Earth and they're looking up at the stars. So these stars up here are all millions and millions and millions of light years away. All of the constellations they saw. But because they moved across the night sky like the sun did, like the moon did, they just moved their way across at the same speed every year. They never seemed to move at all outside of that. They always kept the same positions year after year after year. And they couldn't tell because they look up at the sky and they see from their two eyes, because you think about it, your two eyes, they're only a couple inches apart from each other, right? And those stars are millions and millions and millions of light years away. Those two cameras, the lines that they do, mean nothing compared to that when it comes to parallax. They look the same. No matter which eye is open, the star doesn't move. So they said that, they saw that, and they're like, all right, That proves our theory. Earth is the center. Those things are all a big globe around us. They don't move. That means it's in a set spot in a wall somewhere far away on the outside. It's a big snow globe we're trapped in, and we're the center of it. That's how they used it. They looked up at these stars and said, you know what? That's evidence. Now we have crazy telescopes, these devices out in space that allow us to see everything so up close that we can actually see the difference now. So all of these mirrors, glass, all this stuff takes what information we have and lets these little people on Earth see way far out into space and see all these differences. We can see now that some stars are closer than others, but they're in the same constellation still, because constellations are pictures. Those are things you see in the sky. They're not actual sets of stars that are stuck there forever. Constellations actually move, and now we can see that because we have devices that allow us to see from different parts of the world at the same time, compare them, and notice that stars actually do move away from each other over time. Because if you think about it, we're not just rotating around the sun. We're in the middle of the Milky Way galaxy. We're actually on the outside. So yes, our solar system, we move around the sun like that. But also, if you take our galaxy, here's the center, and as it goes out, we're like out here. So when we're sitting out in the outer bands, we're still going around our galaxy the same way we're going around the sun, just a lot longer to get around, so we're not moving nearly as much, or we don't notice how much we're moving because it's a lot longer to get around a galaxy than it is to get around a sun. If it takes a year to get around the sun and the galaxy's millions of times larger than that, we're not going to notice a difference. But we do know that we are moving around, and constellations are steadily changing. Whether or not we can see them with the naked eye, they are. That's the idea of parallax. How far something is away determines how much of a difference you see between 2 points of reference. Points of reference can be your eyes. They could be 2 cameras pointed in the same direction. Just the idea is 2 different locations looking at the same object and seeing the difference between it and other things around it. That is what parallax is. I can't spell today, but that's okay, because we have things called erasers. Now, parallax, we're not going to go any deeper, but that was today's subject. And also the ancient Greeks with the geocentric model used that to kind of prove their point. At the same time, we went over wandering stars last time that completely threw a wrench in everything they did. But these are the processes of how we started to get to know what we know today and what was even being used way back then to come up with wrong answers that over hundreds of years became more right. And even now, we say we're right, but who's to say we don't find a major discovery in another 100 years that makes everything we know a lie? Now, it's probably not going to happen with all of our technology. There's not much more they could find out about our immediate solar system, but maybe in the future we find some things about those stars that we did not know before. That's all part of science. Maybe you could make a discovery someday that would change the way everyone looks at the stars every night. Well, if you learned anything, or if you have any questions to ask or any comments to add, please put them down below in the comments. If you could, please like the video. That way, one, you can come back and watch the video if you ever want to again, a lot easier. And subscribe so you don't miss any of my content. And also, you can be there as soon as a new video is out. So you can be one of the first to comment, first to be seen, first to be replied to, and also first to get your ideas to me to work for future videos. Thank you again, and have a nice day.